Alright guys, so today we're going to be starting off the BC exclusive non-calculator questions, starting with the differential equation question that always comes up on the BC test, except now we have to deal with some infinite series, but we'll get to that later. First we have the AB part, because this part is always a mix of AB and BC. So we need the second derivative of the implicit function, and this would be, we get dy over dx equals 3 minus x times y squared. And then once we differentiate this, we get d squared y over dx squared. That's perfect. And then this would become negative 1 when you differentiate this times y squared. We use the product rule. And then 3 minus x times 2y times dy over dx. Because remember, this is an implicit derivative. So when you have to take the derivative with respect to x, when you differentiate a y term, you have to include this. So from here, we get to y over dx squared equals negative 1 times y squared, and no, it's plus here, plus 3 times x times 2y times 3 minus x times y squared. And now we can just plug in the point, 1 times negative 1. This would become d squared y over dx squared equals negative 1 times negative 1 squared plus 3 minus 1 times negative 2 times 3 minus 1 times 1. And this would be negative 1 minus 8 equals negative 9. That does not answer part A answer. Here. This would probably be 2 points. In part B, we're asked to create a Taylor polynomial. So first we need because it's a second degree Taylor polynomial, we're going to need the function term of the function. So that's given the derivative at x equals 1, and this would be 3 minus 1 times y squared, yeah, 1 squared equals you can fit here. And this would be 2. And then d squared y over dx squared from this one would be negative 9. And then we have to create our Taylor polynomial equals f of 1 plus f prime of 1 of x minus 1 plus f double prime of 1 times x minus 1 squared. And then we plug in the values and get negative 1 plus 2 x minus 1 minus 9 over 2 x minus 1 squared. There's our answer to part B. In part C, we're being asked to use the Lagrange error bound on this Taylor polynomial to show that the approximation is within 0.01 of the actual value of f of 1.1. So recall that the Lagrange error bound formula states that the absolute value of the error has an upper bound or is less than or equal to the absolute value of f prime of c of the derivative of n plus 1 of c. So this is going to be a maximum value, which is given to us, times x minus, so basically this is the center, we just say 1 to the n plus plus 1 over, let me just put it times here, n plus 1 factorial. So we're going to sub in values here. F of n plus 1 of c represents a maximum on the interval 1 under the closed interval suggested. So we substitute values and say the absolute value of the error is less than or equal to f, the third derivative of x maximum from 1 to 1.1 inclusive times 0.1 cubed over 3 factorial equals, from our problem, 60 times 0.001 over 6 equals 10 times 0.001 equals 0.01. So by the Lagrange error bound, f, the Taylor polynomial approximation differs from f of 1.1 by at most 0.01. So part C answer. Finally, in part D, we're going to use Euler's method to approximate f of 1.4. So it's two steps of equal sides, so step size is 0.2. And we're going to say f of 1.2, and it's an approximate equals here, but I don't think they'll care about it. Make sure you put approximate equals to when you use Euler's method or Riemann somewhere, any kind of approximation on the exam. And this would be for Euler's method, it's basically a series of tangent line approximations. If you've seen the AB videos, we've done that before. So here we would do f of 1 plus 0.2 because that's our step size. We're not going negative like we did in AB problem. Times, now we're going to find dy over dx at at 1, 1. And we found that already to be 2 from the Taylor polynomial. So this would be -1 plus 0.2 times 2 equals -0.6. Well, we're not done yet because we have to do our second step of Euler's method. And this would be f of 1.2 plus 0.2 dy over dx at 1.2 times -0.6. And that would equal to -0.6 plus 0.2 times. And if you look here and do our here, 3 minus x would be 1.8, and then we're going to use 0.6 squared times 0.36 equals, and then you should be getting, after all this calculation that you'll do on paper, you'll have here 1.8 times 0.36. You don't get a calculator, but you could honestly leave it like this. They will take unsimplified answers as long as you do this work, but you should get -0.4704 after all that work. Although I won't do all the calculations here. You'll probably have to do it live on the exam, but remember there's no calculator. I feel like it's kind of unreasonable. Remember that you can leave answers unsimplified on this test. So this was a pretty BC heavy problem. It's rare to see Taylor series outside of question 6, but we'll get to the dedicated series question next time when we go over the Taylor question that's coming up. And that will be the last question of this series of walkthroughs.